Hey, this is Howie. In this video, we're going to be working on fraction subtraction, specifically using mixed numbers with regrouping. In our example problem, we're asked to subtract 6 4/5 from 9 1/3. Of course, our first step will be to find a common denominator between 1/3 and 4/5. 1/3 can be renamed as 5/15, and 4/5 can be renamed as 12/15. Now that we're ready to do the subtraction, I will start by modeling 9 5/15, and then we'll take away the 6 12/15. Let's start by subtracting the 12/15. I will use an X to cross off the parts as I subtract them. 1, 2, 3, 4, 5. I can't cross off anything from the section in white because that's not part of my 9 5/15. So it appears that I'm stuck. I need to cross off 12/15. So far, I've only crossed off 5/15. What can I do? I got it! I was able to show 5/15 by drawing a hole, splitting it into 15 equal parts, and then shading in 5 of them. So I can take one of the 9 holes that I've already modeled and split that into 15 parts. One hole is equal to 15/15. So now it's like we have a total of 8 holes and 20/15, which means it's now possible to X out 12/15. We've already crossed out 5/15, so let's continue from there. 6, 7, 8, 9, 10, 11, 12. And now we can use an X to cross off 6 of the holes. 1, 2, 3, 4, 5, 6. We have now taken away 6 12/15 from the 9 5/15 we started with. So what's left? 2 8/15. Let's take a look at a numerical representation of our work. After finding a common denominator, we first tried to subtract the fractions 5/15 minus 12/15. Because we weren't able to do that, we borrowed or regrouped one of our 9 holes. In this case, a hole is equal to 15/15, so that gives us a total of 20/15. 9 5/15 is the same as 8 20/15. But now we can subtract. 20/15 minus 12/15 is 8/15. And 8 minus 6 is 2. 2 8/15. Another strategy that may help you solve this sort of problem is to see it on a number line. 9 5/15 is between 9 and 10. 6 12/15 is between 6 and 7. Let's think of subtraction as the distance between the two numbers. How far apart are they? As we use this strategy, I want you to step way back, all the way to the time you were a kindergartner, and try to think about how you might have thought of subtraction then. You see, I have a kindergartner, and he's working on subtraction right now. Take a look at how he solves this sort of problem. I'm going to give you 1, 2 Skittles. But I'm going to get 1, 2, 3, 4, 5, 6. Who got more? I have what?
6. You have 6. And then you have 4 more than me.
Uh-oh. Did you see that as soon as I gave myself 2 Skittles, he started to use his fingers to find the difference? He was counting up. And that's exactly what we're going to do using this number line. Let's start at 6 and 12/15 and work our way up to 9 and 5/15. Let's stop at the next whole number. How far away is 7? To get to 7, we need 3/15 more. Now that we're at 7, let's keep counting up by whole numbers. We can move from 7 to 9. If we went to 10, that would be too far. From 7 to 9 is a distance of 2 whole units. Now we're ready to reach our stopping point, 9 and 5/15. To do so, we just need to move 5/15 more. So to find the total distance between 6 and 12/15 and 9 and 5/15, we just need to add 3/15 plus 2 plus 5/15. Because we already have common denominators, that's not such a tough problem. 2 and 8/15. In this video, we've reviewed a few different strategies to solve mixed number subtraction problems. They include drawing a model and using X's to cross off the parts that are being subtracted, using computation with borrowing strategies, and counting up on a number line. You'll notice that all 3 of these strategies ended in the same result, 2 and 8/15. Now it's your turn. Use one of these strategies, or better yet, more than one of these strategies, to solve the following problem. And remember, when working with fractions, the first step is to find a common denominator. Then, use a strategy to solve the problem. Pause the video, and then press play to check your work. Seven and 3/6 minus 2 and 4/6. Now take away 4/6. 1, 2, 3. Need to regroup. 4. Now take away 2 wholes and count what's left. 4 and 5/6. Computationally, borrow from the 7. In this case, 6/6 make a whole, so now we have 9/6. Now subtract. 4 and 5/6. Counting up. It takes 2/6 to get to 3. From 3 to get to 7, it will take 4. And from there, it will take 3/6 to get to 7 and 3/6. Bring them all together, and we get 4 and 5/6.